record and go live on Facebook.
Okay, I think that we can start. Welcome to this section. This section of the conference is dedicated to the relationship between architecture and technology, with a particular focus on the topic of energy. This section is specifically conducted by me. I am Maurizio Sibilla. I am a senior researcher at Oxford Brookes University. I am my expertise is in sustainable construction and environmental design. Thank you for participating in this section. Thank you to the moderator, Dr. Salar, to conduct this section with me. Thank you to the Commit for inviting me, and it's a pleasure to stay here. I hope that this section will be productive in terms of knowledge exchange and interaction. After the section, we have 15 minutes dedicated to exchange opinion about the presentation, question, and to go into detail of your work. I have read your abstract, and I have seen that we have a different approach and different contribution, and it will be productive if at the end of this section we can activate a meaningful discussion about some common point about this the topic of architecture and technology with this specific focus on energy. I'm going to share my screen with you and start with this video recording presentation. The first is the topic entitled Exploring Blockchain in the Realm of a Network of Positive Energy Buildings. This contribution was elaborated by me and my colleagues, George Bloomberg. So I'm going to share and start. Please, I need that you activate the possibility to share the screen. Please, I ask the host to activate the possibility to share the screen.
Dr. Mauricio Bilasari, I think Dr. George Bloomberg. So you are going to do the presentation online because we have already have YouTube presentation, so we can share directly from there.
Okay.
But if you want to do it online, we can go with that since you are the first one.
No, there is a recording. You can launch the video.
So what we need to do from the PDF file, since we have to copy the link from the PDF file, then open the video in your YouTube. After opening the YouTube, just stop it and then go to Zoom and then share your screen, then go to that Zoom Google Chrome page and just...
Yes, I have done this, but I have the option to share my screen blocked by the host. So you have to activate the.
I'm sorry.
Yeah.
Sorry.
No problem. No problem at all. Okay. Good morning. First of all, I would like to introduce myself and my colleagues. My name is Maurizio Sibilla. I am a senior researcher at Oxford University. My colleague George Bloomberg is a senior lecturer at the same school. Our contribution is focused on exploring blockchain in the realm of a network of positive energy buildings. This slide is about the ground on which our work has been developed. The innovation of urban energy infrastructure has become a key action of the European Strategic Energy Technology Plan. The SET plan takes into account a multitude of advanced low-carbon technologies, such as nuclear, solar, wind, among others, in order to achieve the Paris Agreement. However, only
source can generate lost relationships between cities and communities. Nowadays, the high level of maturity achieved by renewable technologies, together with ICT advancement, has made the evolution from fossil and passive management infrastructure to renewable and interactive energy system feasible. However, this new typology of infrastructure has not been codified yet. So, the literature presents different concepts such as active buildings, positive energy block, positive energy district, and energy community, which are the new paradigm on which the energy policies and practices in Europe are being developed. However, established positive energy blocks and buildings has a common practice required development of appropriate tools to allow the local actors to exchange energy within a shared regulatory framework. Technological innovation, therefore, is the key factor to drive the energy transition. In this regard, blockchain technology is a possible solution. However, how blockchain-based energy systems can contribute to local carbon transition is an open issue. And our research is an exploratory research in order to clarify the property of blockchain and the relationship between this technology and the vision of positive energy block. The figure contains a model of positive energy block showing the three organization layers: data, device, and user. Particularly, the transfer of information between the user, the device, and the storage of the information must be protected. And blockchain provide novelty by their ability to hold critical data that, once written, are immutable and protected. For this reason, the blockchain technology is based on cryptography. This is the image is represent the different block cryptographied that use different technologies to use code in order to make the file immutable and protected. However, this contribution will focus more on the relation between this technology and their field of application. So, for example, this flow chart describes how transactions are recorded on blockchain.
Doctor, we have problem with the sound. The sound is very low. So can you check the setting, please?
Can you hear me now?
Yes, now it's good. Thank you very much.
I have the maximum volume of the recording, so I hope
that records are written by individual nodes. We can
still it's slow.
Sorry.
Maybe the setting of your laptop. Can you check the setting of the volume?
I have checked is the maximum value. From my computer is the volume is quite high, so I don't know why you are so low.
Let me try from my side if I can present it from the beginning, because I think the audience didn't hear very well.
Okay.
Can I?
Yes, please.
Please, you can.
Is it okay now?
No, it's mute.
Without sound.
Let me share my screen if it's possible. Maybe it will work.
Of the information
What about now?
must be protected.
We have problem with the 1 minute. We try to solve the problem.
Called critical data that once written are immutable and protected. For this reason, the blockchain technology is based on cryptography.
Yep.
This is the image is represented the different block cryptographied that use different technologies to use code in order to make the file immutable and protected. However, this contribution will focus more on the relation between this technology and their field of application. So, for example, this flowchart describes how transactions are recorded on blockchain. In this diagram specifically, arrows show the direction of the record that records are written by individual nodes. We can suppose that these nodes are nodes of a positive energy block. Then agreed upon and distributed to other nodes on the network. So the concept of blockchain is about the network of consensus, where each member of the community are informed about the document produced. So, in conclusion, our work seeks to establish the role of this technology towards the organization of the so-called self-organized energy community, where each citizen can sell their energy, can activate energy, peer-to-peer energy exchange, but within safety framework. And another characteristic is that these energy flows can activate in real time, and these can revolutionize the sense of making infrastructure. Thank you very much.
Okay, thank you. I think that there was some problem with the synchronization. We can go ahead in order to respect the agenda of our
about the storing of all the code what you have done. Okay.
Okay.
Not dumping multiple times. You just if you want to observe that multiple regions, you just need to click.
Dear Dr. Sibila, sorry. First of all, I would like to thank Dr. Maurice Sibila and also Professor Dr. George Bloomberg. I didn't know that he will join. That's why I would like to welcome Dr. George Bloomberg, and I would like to thank him as well, providing such a great research so that you will discuss at the end with the authors. So welcome to Dr. George Bloomberg. I thought that he is also here. And we shall continue with the second one, as you mentioned, with your permission, dear Dr. Sibila.
Yeah, yes, of course.
Today I want to introduce my team and introduce our presentation. Systematization of features and recommendation regulating architecture and urban planning and placement of university hospitals. In the civilized world, the state of development of the medical industry indicates the standard of the social life, the attitude of the health of citizens, care for the health of future generations. This phenomenon is caused by many factors, including environment pollution, lack of the gradual and timely architecture and modernization of the medical system, limited access to quality and modern health care, lack of the culture of healthy living, prevalence of self-medication, untimely treatment and abuse, numerous chronic diseases. The only way out of this situation is to introduce step-by-step change without abrupt and cardinal instant updates, which in the approach provide a basic for more correct adaptation and coordination. Then studies in architecture and urban development of healthcare in the leading countries like United States, United Kingdom, Germany, France, as well as studies of success factors in leading countries of the medical field like Hong Kong, Singapore, and United Arab Emirates, evaluated a number of patterns and direction of development and urbanization, among which one of the most characteristic in the consolidation for the structural and multifunction of the newest medical institution. Therefore, in the following context of the study have been attempted and introduced as the main design features of the university hospitals, which are the next evolutionary step in comparison with clinical hospitals. The closed type of the post-Soviet medical institutions, the university hospitals are clinical hospitals, where medical departments operate and where young doctors undergo internships. The example of clinical hospital are the Kiev Clinical Hospital number 8, the Dnipro Clinical Hospital number 9, the Minsk Clinical Hospital number 1, and the National Clinical Hospital located in Russia. The university hospital provides a complex combination of medical diagnostic, rehabilitation, training, research, and experiment functions, combines them and interacting is in one multifunctional complex located within the same territory or in different areas. University hospitals, as a rule, otherwise state status and are designed to serve the population of the whole country without connection with the place of residence of the citizen. Based on those provisions, the capacity of the university hospital should be calculated at least 800 to 1,000 independent beds. We talk about historical experience of the university hospital design. The first of all is the university hospital Hamburg Center, located in Hamburg, Germany. Next example is the University Medical Complex Freiburg, located in Germany. The Jonas Gutenberg University Medical Center, located in Mainz, Germany. Today, the architecture of healthcare facilities is gradually losing the features of the architectural shell for the technical organization of the therapeutic process, and itself acquires certain therapeutic preparation. One of the important trends is also the use of environmental design approach in the design of medical institutions, which creates the basic for sustainable development of architecture in the field of the health care. And if talk about example, one of them is the Queen Elizabeth University Hospital, Glasgow, Scotland. Another example is University of Montreal Hospital Center, located in Montreal, Canada, and Koga University Hospital located in Koga, Denmark. Today, the university hospital is one of the most promising and effective forms of organization of hospital structures. This is primarily due to the fact that the university hospital is a multifunctional medical institution, which within the territorial boundaries of the one complex combines and synthesizes the interaction of a number of related functions. For example, multidisciplinary and specialized medical education and training, medical profile research and experimental production, as well as many ancillary services, with together create the conditional for an emerging effect in the work of the hospital. It is possible to design university hospitals both in the new suburb area, free from the surrounding building and with a significant potential for landscaping of the medical complex. In this case, it is advisable to design a centralized building of the university hospital with a fairly extensive form of small and medium-sized building, which in case of future need will allow more freedom to expand the health care facility. In this case, when it is decided to create a university hospital in the existing urban environment on the basis of the expansion of an existing hospital or educational medical institution, it is advisable to design a centralized building with a combined volume of high and medium stories. The main conclusion is the understanding that each university hospital is a unique object and cannot be designed as a typical project. In each specific case, it is necessary to conduct a thorough project study together relating the task, goals, capabilities of the future hospital, the characteristic of the territory, the living population, etc. Thank you very much for your attention. Good luck and good day.
Thank you. I think that you can continue to share. Thank you very much.
Dear colleagues, welcome
Thank
to
you.
the presentation
Thank you.
called Contemporary Adaptive Systems of Architecture and Structural Engineering, State of the Art and Future Perspectives. My name is Watkins from University, Turkey. Presentation has 4 sections. The first section, I'm going to make an introduction about the main concepts of adaptive systems in architecture and structural engineering. In the second and third parts, I'm going to summarize types, technology, and contemporary applications of adaptive systems. In the last section, I will try to construct a future perspective for these systems. The concept of adaptation in architecture goes back to ancient times. Throughout history, architects have always searched for methods to design adaptive buildings and building parts that can adapt to ever-changing environmental, spatial, and functional requirements. Technology became an increasingly important factor in facilitating architectural adaptation and innovation, especially after the last decades of the 20th century. The developments in automation, computation, and material science have also facilitated the applications of adaptive systems. Due to these developments, adaptive systems of the era have all been integrated with sensors, control intelligence, and actuators. These systems have a strong interaction with the physical environment and users. This interaction has created a demand for these systems. This presentation and in my paper, I summarized adaptive systems and concept of adaptability in 4 groups. These are adaptability in structural systems, adaptability in architectural components, adaptability in building envelopes, and adaptability in materials. It is impossible to explain all these subgroups and their principles in this short time. And for deeper information, you can read my paper. But here in this presentation, I would like to emphasize that the concept of adaptation has a potential to change our design approach. The structures first. Conventionally, our building environment is static, and building structures in its environments are designed considering the worst situations that they may face. This means the cross-section of a conventional building structure is always more than the needed size at ordinary situations. The foreseen worst situations are very rare and sometimes never happen during the life of a building structure. This means we may be wasting materials by this conventional design strategy. And adaptive structures can be a response to this problem. One of the primary philosophies of adaptive building structures is to design the structures as light as possible and well prepared to rarely seen binding load through an active manipulation of the structure. Studies on active structural control with sensors and actuators, there are many deployable examples which search for adaptation via geometric transformation as well. Flexible scissor bridge in Geneva is an interesting example for deployable structures. While many well-known deployable bridge structures have only one active geometry and cut the pedestrian or vehicle flow at their contracted positions, this bridge structure can be active at any position. You can see the deployment process of this bridge structure in the video and the figure. Movement on the adaptive system technologies has not only affected the structural engineering, but also the special characteristics of the buildings. Architects of the era have realized that the buildings or building components can interact with the user or create multifunctional spaces for different uses at the same architectural space. As a result, a novel design conception, which is completely based on adaptation, has emerged. In this conception, architects and designers aim to design buildings that are flexible, interactive, multifunctional, sustainable, and future-proof, rather than fixed, immovable objects that are stuck in a specific context and time. This novel understanding has an important potential for the future of our planet. It is known that the construction industry is responsible for almost 40% of the carbon emissions, and attempts for multifunctioning may decrease this ratio. Stage designs of color systems for different multipurpose homes are a good example for this design understanding. Instead of constructing several flat and inclined walls for different functions, capacity, and special qualities, these multipurpose walls change their geometry, capacity, and height according to the number of the audience and necessities of the function. This means it's possible to obtain numerous spatial or architectural alternatives in one whole. This situation creates remarkable spatial efficiency. The concept of adaptability is very common at design of building envelopes as well. This is because envelope is the physical interface of a building with the physical environment and the urban context. This means building envelope is not only the group of surfaces separating the building from the exterior climate conditions, but also the interface to interact with the city and the society and the street. Adaptability in building envelopes can be realized in two groups: climate adaptive building shells, retractable roofs, shading devices, and adaptive glass technologies are mostly in the first group because of their great efficiency against the environmental conditions such as wind, rain, and sun. Adaptive shading systems and foldable systems are so popular climate adaptive building systems in architecture. The second group of adaptive facade systems are the performative skins. Interactive facades and media walls, which create interactivity between the building and the user, can be expressed in this group. These systems mostly do not have any climatic aims, or these aims are not the primary design objective. Instead, movable or interactive features of these buildings play a part in the architectural aesthetic as the interplay of image and technology. The movable facade of the Bond Finance Center is an innovative example for this group. You can see this building in the figure. Due to the rapid development of computer technologies, design computing, automation, and material science, the demand for such systems will continue rising. If structural and technical advancements drive this trend and demand, we could be approaching a specific turning point in architecture where technology is directing architectural aesthetics. At this point, it's possible to ask, what is next? In the next few years, it will not be a surprise to see the robotic structures which allow huge simultaneous transformations in a few seconds. Again, it will not be an unexpected situation to see robotic systems constructing the buildings. The research studies on smart materials reveal new materials every day. For this reason, it will not be wrong to predict that these materials will be much more common in the construction industry and our daily lives in the future. And of course, by the help of material technologies and active structural control systems, it will not be wrong to say that the buildings will be lighter than today. At this point, an important question may be asked. Are the architects, engineers, and the education systems ready for this change? A cross-disciplinary approach is crucial for the design of adaptive structures. It's very clear. This is because the design area has always been at the intersection point of architecture, structural engineering, and mechanism design. Material science and mechatronics have already joined this intersection for a few decades. The designers of adaptive systems should be aware of the state of art in all these disciplines and should deal with the design problem in a cross-disciplinary manner. This means the design and education philosophy of today should be updated according to the needs of the era, which doesn't exist at the moment. Feel free to ask questions.
Thank you. We can move from the last presentation for this part.
Perfect. Thank you, dear. I think we finished. There are three presentations that we have. Let's say, shall we have roundtable, or we can continue, dear Dr. Mauri Sibila? Are you going to have roundtable to discuss these three articles to let them to have discussion with the authors? Or what we do, do you have any question from the authors to ask them to introduce themselves a little bit?
In the meantime, that we can collect this question, and I invite all author and participant to make their reflection. I would like also to point out some common point among this presentation in terms in terms of relationship between the technologies and architecture with this specific focus about energy. I think that all contribution can be interpreted with regard to this focus. For example, the first contribution in terms of economic tools to manage the transition. The second contribution can be interpreted with the need, for example, to establish procedure to identify the role of specific building typology within our territory. And the next, also the adaptative structure can have a relevant role in terms of to reduce the impact of our transformation in terms of environmental impact and capture the potentiality from the environmental cyclical variables. So if author want to clarify some aspect of their work, or there is any question, please, I invite you to share your opinion with us. Okay, thank you. If there is no question, I invite you to follow the second section that starts in a while. Thank you very much for attending this presentation. Bye.
Thank you, Doctor. Dr. Maurizio, do you hear me?
Yes.
I think if we can assure that the authors are here, let us to start the next session in order to get more time for the discussion for the last round table. What do you think?
I agree. I agree. So we can. I don't know the problem.
Just first, let us to start to know. Let us to check if the authors are available.
Okay.
Because we are a little bit in advance.
Okay.
You can ask about the author.
Yes. If there is the author of the paper entitled Evaluation of Photovoltaic Noise Barriers Design Criteria, a case study in Istanbul, we can start to the presentation. The author is here?
Yes, I am here.
Okay, thank you. I check also the other contribution. There is the author of Environmental Performance Analysis of Earth Insulation Glass Fiber Reinforced Concrete Facade Panel. Professor Nurai or other colleagues? No. And the last one was the paper entitled The Micro District, a Smart Sustainable Vision in the Architecture and Headquarter Buildings.
Yes, here.
Okay. So I
sorry,
think that
sorry for intervention, but I want to. There is a title of a new design proposal for perforated solar screen. I don't know. This is the title. I think you skipped to mention. We have.
I skipped to mention because it was in the first section. So I don't know, it now moved in the second section. It's okay. There is the author of this paper.
Yes, if he's...
Okay, we can start from this. That was the last.
Okay.
Okay, we start with the, please, if the host can share the presentation of a new paradigm, a new design proposal for performant solar screens and optimization in terms of solar control.
Hi, my name is Fatma Zorluchala. I am a doctorate student at architecture and I am a research assistant at Yıldız Technical University. The title of our publication is a new design proposal for perfect solar screens and optimization in terms of solar control. I will explain our research with the following titles. The building envelope separates us from environmental conditions and provides creating a comfortable interior environment. Especially transparent areas are one of the most important factors affecting indoor comfort conditions because they are the most effective building envelope components in solar gains. Solar radiation should be controlled before it gets the inside of the buildings, and it is possible with the use of exterior shading devices. Nowadays, the use of the perfect solar screens is increased, especially in large glazed facades. In this study, the perfect solar screen design proposal with an approach with difference from the previous studies was examined especially for the classrooms. The perfect solar screen proposed by different methods has been optimized. Within the scope of the study, a new design has been proposed for the use of perfect solar screen. Verification of the model and calculations was made with the measurements. The proposed design has been optimized in terms of harmful and helpful solar radiation. As a result of optimization, the best perfect solar screen was optimized again according to the twist angle for maximizing view while minimizing annual sun exposure. In addition, thermal comfort conditions and inner window surface temperature have been evaluated according to the whether the optimum perfect solar screen is used or not. The classrooms on the university campus in Istanbul was selected for investigation. Meteorological data are given in figure for Istanbul, which has temperate-humid climate. An existing classroom on the southern facade was determined as an example with a large number of occupants and a large volume on the university campus. The selected classrooms is B502 and is located in the south of the building on the 5th floor. The properties of the classrooms were defined. The following data were determined by measurements. The existing classrooms was modernized using Grasshopper. Simulations were conducted using the same program. Grasshopper integrated evolutionary optimization tool based on genetic algorithms was used for optimization. The harmful solar radiation performance was calculated and optimized. The optimizations were made by calculating solar radiation coming to the window surface. Optimization has been done so that the harmful radiation is the least and useful radiation is the highest. As a result of solar radiation optimization, the best perfect solar screen was optimized again according to the twist angle for maximizing view while minimizing annual sun exposure. The figure showed the adjustments were made for the thermal comfort calculations. Another step of the study is verification of the calculation by measurement. Verification was conducted for 3 classrooms. Measurement and calculations were made when the classrooms were unoccupied for the existing station. Thermal comfort measurements were performed with test 480 device. The measurements were conducted at 3 points in classrooms and calculation results verified according to the average of the values of these points. The verified results are given in figure. A similarity was obtained between the measurement results and the calculation results. The results are the more similar with the windows closed. It can be said that comfort is provided when the windows are closed during the winter months. The measurements were, the first design variables are the dimensions of the Voronoi cells, the width of the horizontal shading dividers, the distance between each other, and the twist angle. Figure and table show the perfect solar sequence, its variable and its variable evaluated. The horizontal geometry is twisted around its central axis. The width of the horizontal geometries is equal to the distance between each other, so that they rotate around the axis and don't intersect with each other. The dimensions of the Voronoi cells vary according to the different cell radius. Even if the width of the geometry changes, the preparation ratio is the same when the cell dimensions are the same. Different from the specified design variables, the rotation angle was also optimized. The rotation angle was same central axis. The rotation angle was optimized for the best result after the first optimization. The positive angle represents the rotating horizontal geometry clockwise. The optimized perfect solar system has been recommended according to the all year use. When we come to the results of this study, the first solar radiation optimization was done for twist angle and other variables. The optimum results were obtained when the twist angle was 0 degree. The dimensions of Voronoi cells radius were defined as 0.4 and the width and distance as 0.15 for the best twist perfect solar sequence. Then optimization was performed with the rotation angle variable for these geometries perpendicular to the facade. 30 degree was determined as the best angle as a result of optimization according to the rotation angle variable. These calculations were made for the annual situation. We evaluated the optimum perfect solar sequence in terms of twist angle for Regionality. In this case, the best perfect solar sequence when the twist angle is 720. Solar radiation is the least with this perfect solar sequence in the summer. As a result of solar radiation optimization, wave and annual sun exposure optimization were done for best optimized perfect solar sequence according to the solar radiation. Twist angle was the design variable for this optimization. The twist angle was determined as 0 degree best twisted perfect solar sequence. Solar radiation were calculated for the best 3 perfect solar sequence determined according to the annual sun exposure and wave optimization. When the twist angle changes, a lower amount of solar radiation was calculated in summer as determined in the results. It has been calculated that the effect of the perfect solar sequence, which gives the best results, determined by optimization on thermal comfort and window in surface temperature. Predicted mean mode values obtained as a result of the calculations were evaluated according to the limit values in the standard. According to the standard, if PMV is between -0.5 and plus 0.5, it is considered as comfortable. If the determined perfect solar sequence are used, the thermal comfort conditions have changed positively in comparison the existing situation. The window indoor surface temperature decreases with the use of perfect solar sequence. The decrease in window temperature is higher in summer months as in thermal comfort. A new design proposal presented by considering the basic principles in terms of providing solar control by perfect solar sequence within the scope of the study. The solar radiation view and annual sun exposure optimization were done for the best optimized perfect solar sequence. Consequently, it has been observed that the use of 0 degree horizontal geometries is the best for twist angle design. When the twist angle changes, a lower amount of solar radiation was calculated in the summer. It is possible to find and apply optimal results according to the modes for the perfect solar sequence suggested in this study. Better results can be obtained if it is designed as a kinetic. The proposed design allows kinetic applications. design proposal can be developed for the east-based facade by using the method of this study. It is necessary to analyze and find the optimal result for proposed perpendicular thickness to be used in the existing new buildings. Otherwise, the desired shading devices will not be able to perform their original functions. Thank you.
Thank you. We can go ahead with the next paper entitled Evaluation of Photovoltaic Noise Barriers Design Criteria, a case study in Istanbul.
Perfect. Thank you, Dr. Mauri and Fatma Zorloku and Dr. Kulay. So we shall go to the second one, as you mentioned. Just before that, if Dr. Mariam is around, I'm going to give the host to her to. I should go to the session C. Professor Dr. Madrigal some health issue that needs to go to hospital. That's why I have to be in session C. If Dr. Mariam Iranfar is around.
Seems no.
Or Dr. Salar, or I can give the host. Would you please?
Dr. Horach, let me to check out with Dr. Mariam if she is around. She says I am in the platform. Yes, she is in the platform. You can talk to her.
So I make now to be safe side Dr. Mariam host because I have to leave. Dr. Mariam, would you please share the second our author's YouTube link, please? Evaluation of the photovoltaic noise barrier. Yes, Dr. Mariam, can you hear me? We can't hear you. You are mute. Yes.
Yes, doctor. I am here.
So please,
I can.
If you have the program, open the presentation with the title of Evaluation of Photovoltaic Noise Barrier.
1 minute, I will.
Doctor, this is my presentation. Tarhan Hasmadan. Photovoltaic noise barriers.
Evaluation of 1 minute.
Search it, Control F, evaluation.
Evaluation of photovoltaic noise?
Yes, please.
Yes.
After opening the YouTube file.
Yes, I'm opening now.
Please start to share your screen by going to your Internet Explorer.
Okay. Now it is opening. Now I will. I share it through the Internet Explorer.
Yes, please.
My internet little bit is very slowly. Now I am opening and sharing. Share it.
I'm sharing by myself. Please try to learn it for the next one. And
okay.
Hi, dear conference participants. Welcome to my presentation. I'm Hasmadan, a PhD student from the Technical University. I'm current research assistant at Istanbul University. I will give you a presentation about evaluation of photovoltaic noise barriers in terms of noise control. The evaluations were carried out following I have organized the talk in the following section: introduction, methodology, design of PD and the alternatives, environmental noise model, evaluation of findings, and discussion and conclusion. The first point concerns the issue of air traffic noise. Although noise and energy in general do not have a direct relationship, the transportation sector is responsible for a major share of energy consumption. Additionally, transportation has many phases related to environmental pollution, such as air and noise pollution. As a result, noise control measures are needed in heavy traffic urban areas to mitigate the impacts of road traffic on energy and noise pollution. Noise barriers can be the best solution when no noise control measures are taken neither at the noise source nor at the receiver. Noise barriers are used as a structure for solar panels and installed noise barriers. These structures are applied in low barrier zones, such as roadside, provide both renewable energy generation and comfort for the residents. For light area in the supply, which is the biggest disadvantage of solar energy application and the other kind of this technology. First of all, the factors affecting the performance of PV and lead were investigated with the literature review. The results of the literature review are summarized in tables. Non-alterable features depend on the highway, environmental, and climate conditions. Alterable properties are related to design variables. The parameters affecting all three performance indicators are highlighted with a red pen. Barrier height, barrier length, and the tilt of deflection edge are related to the barrier design. As a matter of the literature review, various barrier sections were designed with common criteria. To analyze the effects of barriers, evaluations were carried out on a case study. Within the case study, an existing residential settlement exposed to noise levels above the new value along the highway was considered. The case study area given in figures, the 21 meters wide highway is in the shortest of the residential area. The intersection of the highway and the settlement where the PV&D was designed as an azimuth envelope -30 degrees. There are 25 residential blocks with 5 and 9 floors. In the settlement, the closest road highway is 20 meters. The farthest road is 194 meters away. It is envisaged that the PV&D installation will be used as an electric vehicle charging station for residents, but these can be in the recommended consider or not. Flow chart of the study consists of design, model, and evaluation steps. The scope of the study is limited to noise control. The PV&D schematic sections and design variables are shown in Table 2. The barrier top pitch has been 2 meters, 3 meters, 4 meters, and 5 meters. The wall height of the PV&D is considered 1 meter and 2 meters. These angle values are periodically estimated for this region. Optimal peak angles for monthly periods annually were calculated via the optimization tool module of PVC software. Tilt angles lower than 25 degrees, as you can see in graph, weren't included in the calculation as they include the dust accumulation on the panels and additional bakery fat yet. Traffic flow characteristics of the highway are given in Table 4. The total number of people passing the highway is more than 24 million annually. The figure on left reveals the brief noise map of current situation were generated in Country. In validation process, actual noise measurement and model outputs were compared. The difference between measurement and model results is within the acceptable range measurement point. Where traffic noise is dominant. However, some points are above the limit range. We keep the noise sources that cannot be intervened and affect the background noise, such as border elements, children's playground, and construction activities. Figure shows the noise levels on the facade in the daytime. As stated in the regulation, the noise level should not exceed 63 dBA during the daytime period. The evaluations are partly divided into two groups. All blocks in the southern expressed in all, blocks in the first row expressed in 1R in graphs. 24% of all facades in the southern one, 55% of the facades in the first row blocks are exposed to the noise level above the limit value. Finally, in the evaluation step, a general analysis was made first. Then, to examine in detail the effect of barrier variables and noise reduction in the southern one, the assessment has been discussed in three different fields: flows, distances to the barrier, and facade directions. Simulation outputs were evaluated according to the pillar point ratio above the limit noise level, generally were shown on the vertical axis in the graphs. Barrier design variables were demonstrated on the horizontal axis of graph. As you can see in the chart, shortly increasing the height of the barrier, width of the diffraction edge, and the inclination angle improves the performance of the noise level. Continue the noise analysis. Now, to find out the effect of barrier alternatives on the floors, target of the borders belong to the highway were analyzed. 3 dBA difference in noise level can be detected by the human ear. In this context, 100% of the alternatives provided usable noise reduction on the first floor, 92% on the second floor, 41% on the third floor, and 1% on the fourth floor. When the noise levels on the fifth floor were examined, it was seen that no barrier alternative provided beneficial noise reduction. Then, the effects of the barrier alternatives are interpreted by considering for all facade floors in control blocks. The effects of the best and worst alternatives were compared. H equals 1 meter, T equals 2 meters, and 27 barrier reduced the number of receiver points exposed to noise above limit value by 65% on the first floor, 17% on the second floor. No improvement was observed in the third, fourth, and fifth floor. Barrier type depth, H equals 2 meters, T equals 5 meters, and 56 degrees Newton provided 100% improvement on the first and second floor, 75% on the third floor, 46% on the fourth floor, and 17% on the fifth floor. To observe the effects of PV and D alternatives on blocks at different distances from the highway, the ratio of first floor blocks to the total number of receivers exposed to noise above the limit level was analyzed. Analysis results are shown in figure. In blocks with distances of 21 meters, 29 meters, 36 meters, and 41 meters to the barrier, in the base case, the percentages of receiver points above limit level are 75%, 75%, 70%, and 60% respectively. With the barrier alternative providing maximum noise reduction, the rate of receiver points exposed to noise above limit level was 32%, 35%, 25%, and 10% respectively. For evaluation according to facade direction, A1, A2, A3, and P1 blocks were considered. Among these results are shown in figure. The southeast facade parallel to highway was exposed to maximum noise. Acoustic comfort was provided on the northwest facade of all blocks. Because of the receivers on the northwest facade were on acoustic shadow zone. To sum up, increasing the height of the barrier and width of the diffraction connection surface increases the most. The information of the barrier edge is positively correlated with loss control. High-rise buildings should be located away from the highway. In this way, more population can be protected from loss. In the spatial planning step, non-sensitive areas should be designed for in the acoustic shadow zone. Towards the end, I'm hoping the study guides the designers in determining the most effective area alternative under different conditions. Thank you for listening.
Thank you. Following the program, the next presentation is environmental performance analysis of heat insulated glass fiber reinforced concrete facade panel.
Sorry, dear Maura, I see this YouTube. Which one we are going to continue with? Dr. Maurice.
The micro district, doctor.
Yes, the last one, I mean.
The micro district is, yes.
So is Mariam Iran Faris around, or Dr. Salar, would you please try by yourself one more time to see it is working? Dr. Salar is the...
Doctor, I can share it. I opened the
please
file.
Thank you, Mariam.
Let Mariam to share first because mine is very weak.
Perfect. Thank you. Press the CC button and just full screen and play. There is no sound. Don't, please, Mariam, unmute yourself. Otherwise, it will not unmute yourself, so we will be able to hear.
Hello, everyone. It is an honor.
I think there is a problem with the presentation or the sharing.
This conference. My name is Peja, and
I'm going to play. Is it working now?
Our research of the smart.
No, it's delaying.
Smart for... So what?
Hello. Hello.
Is the author is here with us on the platform?
Yes, I'm here.
Can you share from your side, Dr. Horakh?
Sorry.
The reason
can I
I'm
share?
not sharing is
Can you share?
I'm going to share. Yes.
By yourself?
Yes, sure.
Yes, please.
So, Dr. Mariam, please stop your sharing.
Yeah, stopped. I stopped.
So, in that case, Mariam,
is it visible?
Did it stop the sharing?
You stop the sharing, Dr. Mariam, you stop the sharing.
I stopped the sharing.
Okay.
Yeah, it's okay. Can you hear the recording? Can you hear the video?
Still didn't show up for me.
It didn't show up.
So I'm going to, I don't know, we have to find a solution. So I'm going to share for this one as well, but please, dear valuable authors, stop your sharing. I'm playing the video.
Yes, sure.
For me to be part of this conference. My name is Feja, and I'm going to represent for you our
Is it
research
working?
of a more sustainable vision in the
Yes.
architecture of the headquarter building, the micro district. So this is how we structured our research, which is the introduction and the background, the current situation that's happening within the headquarter building, the aims of this study, the method that we use, the literature review that is supporting our aims, and the case studies, and finally the discussion and the recommendation. So to begin with, a large part of how people define who they are by what they do. Work can be a key part of our social identity. We use our membership of a group, organization, or profession to build our sense of self and find meaning. Moving from this point to the point of employees spend 70 to 80% of their time in their workspace from the age of 21 until the age of retirement. As work, as we all know, usually do not provide a universally positive experience. The poorly designed workspaces, the challenging work environments, the lack of understanding of the human behavior, and so on, create the necessity of examining the employee's life, creating a better understanding of the application of this psychological aspect, that will lead to a better system, raising the satisfaction and productivity. So according to the Workplace Trust Statistics from 2019, stress, anxiety, and depression are accounted for 55% of the US employees experiencing this kind of stress disorder in their workspaces. Similarly, statistics of MENA region shows that nearly 7 in 10 people, which is 69% of the employees, are suffering from stress disorder. And one of the main reasons are the built environment of the workspace. So the building design has the potential to cause stress and eventually affecting the human health. We all know that stress is a dynamic procedure that is caused by the individual itself. But however, understanding the physical environment that has a significant role in enhancing and decreasing the stress level in the workspace that will create a leap of change in the innovative workspaces and create a leap of change in the employee's life. So this study is trying to look at the rigid headquarter workspaces and understand the way of designing a new building typology that enhances the work environment and maximizes productivity, creativity, and well-being. And followed by answering a question of how can a design of a sustainable headquarter workspace that allows employees to connect with co-workers, interact with the community around, live and enjoy while working. So the process by which this is done is to further address the design issues through observing the current existing situation in the workspace, the factor that is affecting the human behavior and the level of productivity, and reflecting the architectural implementation of the new innovative work spaces by the literature review, followed by case studies to give us more insights about this kind of places and how can we fix them and implement the good let us say, trends within our buildings, our new buildings design. So firstly, we have to understand the environmental effect on the human behavior, which is there are factors that are affecting the employee's behavior, which is the internal forces and the external forces. The internal forces is the ability of the employees to participate, feel comfortable and energetic within the workspace, while for the external forces, it's including the collaborative workspaces, the interactions, the support of the leaders and the employees for themselves, and even the open team environment, all reflecting on the perception of the individual. The second thing is the emotion and the environment, which is the forgotten dimension. People always tend to forget about the emotion and how it reflects on the behavior positively and negatively. So the most important thing from this topic is the social capital, the way the employees interact with each other could promote a sense of trust and vitality, which will lead to a sharing experiences and knowledge, generating new ideas, enhancing the level of creative thinking, and so on. This is all leading us to the work environment issues. The study has been conducted by the Ohio State University, tracking the stress level and the impact of the built environment on the workers and the employees. They divided the employees into two groups and into two buildings. The first building has poor lighting and color with low ceiling, lack of spatial organizations, and so on, while the second building was a new office building with an open plan layout, skylights, and colorful interior. The study showed that within 1 year and a half, the employees in the old building felt more stressed and have more anxiety from those in the newer building. This reflects the importance of the built environment and the appropriate organization of the interior on the people and their behavior and their stress and mental health. So after observing the workstations issues, contemporary trends have been emerged in order to influence the design of a workspace. Number one of the trends is the psychological effects of the openness. Is having a place that is open, have this kind of transparency, the glass between one space to another, will lead to create a mutual relationship and interaction between the individual and their work, sharing knowledge, creating this kind of happy place and stimulate the creativity. Going for the open plan layout of the floor plan affects the movement within the building, the visibility, the accessibility, and so on. And this all affects on the user perceptions and satisfaction. So a comparison has been conducted between two layouts of the open plan layout. Number one is the traditional open plan layout, while the second one is the organic open plan layout, as you can see in these slides. So the organic open plan layout had the circulation points to be more interactive and social engaging, while for the also for the organic open layout, an excellent visibility and accessibility is obtained within this kind of a layout. But we have to know that workspaces with open plan layouts has less control over privacy and security. So the noise is an issue where there is no barrier there. So according to the Harvard Business Review, 60% of the workers in the open plan layout cannot concentrate, while 13% cannot access the quiet place for them to have a quiet moment or to talk or even in the phone and so on. So the solution for this is to create a hybrid layout. The hybrid layout is a balance between the interactive and the private spaces in order to create a multi-zone workstation that meets the collaborative open spaces and the private concentration workspaces and serves everyone's needs and requests. This is one of the examples of the hybrid layout. We're having the flexible open plan layout, having the closed spaces, the glass wall that keeps the spaces open to each other, but having a degree of separation and so on. Also, the flexibility of the spaces. It allows rigid spaces to move and change at the moment of notice, while thinking through all aspects of spaces from, for example, applying movable walls, furniture, and other components that they create a flexibility within the design. One of the most important trends to have within the headquarter building is to develop a sense of community. Everyone that is engaged within a workspace is influenced by the design one way or another. So researchers found that creating a single-story building is better than having multi-story building for the interaction. Some strategies have been suggested to strengthen the social interaction, which is number one, the atrium, that will reduce the barriers and create solutions for daylight penetration. While for the corridors, is to design the corridors in a way that encounters the right places and attracts people to have this kind of interaction within them. Then introducing elements of the nature and visual escape. The positive effects of the nature that can create an environment that will help to focus and reduces the stress levels for the workers and the employees, while creating sceneries of nature in the workspace invites us to take breaks from the surrounding and from the distraction and enhances the creativity and productivity. We have also to minimize the noise distraction. The noise pollution can have a significant effect of these challenges on the challenges of the employees' positive behavior. So having zones of concentration, locate noiser teams and parts of the quieter teams using acoustical devices and spaces need to be well occupied with sound absorbing materials. These are all strategies that have to be considered with while designing a workspace and a headquarters. In the previous topics, the 21st century needs the factors, approaches, open, innovative work environment that would stimulate creativity and productivity is discussed. However, taking a closer look on the headquarters in Bahrain is an essential part to address the issues, pair them with the above research, and treat for a final solution. So the main three headquarters is the Al Baraka headquarters, Al-Arcapita headquarters, and AXA corporate headquarters. So as you can see in the picture, the architecture and the form of the building has a basic form, either square or rectangular. They have weak indoor and outdoor relationship with the three headquarters. As you can see in the picture, these are the only indoor-outdoor relationship that is really not well designed to accommodate people and to interact with each other. So an open plan layout is the main approach of the interior, where most of the employees and workers are open and visible from one to another. Al Baraka and AXA headquarters has a range of workplaces such as interior clean corridors, closed pods, meeting areas, and so on. While Arcapita has more typical office floors with floor-to-ceiling partitions, wall for high privacy. So to reflect, it is clear that the quality of the headquarters in Bahrain is not enough advanced to suit the employees and the users' everyday needs. A workspace is not just a desk area with a computer that is dedicated to the individual, but on the contrary, it is a place for people to gather with different backgrounds, different knowledge, and different kind of ability in order to interact and share this kind of knowledge and benefit each other. Therefore, a headquarters should emerge social engagement, innovative thinking, and support the well-being of users by providing sufficient components and spaces and also spatial organizations. So finally, this research was undertaken to help establish answers to the research question, which is what are the aspects that will enhance the headquarter workspace in order to create more productive environments and enhance the well-being of the user. In terms of this aspect, the finding of this research argues for the need of creating a dialogue between the architecture and the user by understanding the human behavior and the factors that affect the wellness. And then when a work environment is creatively designed, the ability to generate new ideas and stimulate creativity will emerge. So we have to know that in a workspace, people have different goals, different moods from one person to another. So some of them need quieter areas, and the other one need playful areas to interact with people around them and to get inspired. So creating diversity in spaces allow people to get inspired in different ways. Proper facilities is a must to have within the workplace and the headquarters, and creating interaction possibility is an important factor to consider. So as a conclusion and a recommendation, reflecting a district or a mini district within the headquarter building could lead to create an effective environment for people to have more work-life balance, because reflecting a mini living that supports the playfulness, the work, the liveliness, and the layers of the livability, the public engagement, and so on within the building could create this kind of daily life practice and that reduces the stress and increases the productivity and creativity. So thank you so much for listening and have a great day.
Thank you very much. I think that we don't have other contribution. We have, and it's correct, we don't have other contributions. So,
hi there, thank you for joining us today.
Yes, we don't have.
Joining me, Ben, and I've got Stephen here with me as well.
Yes, I would like, of course, I invite the participant if we want to clarify some aspect of made question. Other side, I start with some conclusion. after these other three presentations, I think that a reflection about the role of architecture and the relationship between architecture and technology emerged from these three papers. The first two are focused on very original and a non-conventional aspect respect to the integration of renewable technology. And I think that these studies are necessary in order to make the renewable infrastructure as a common practice and a reliable system, not only in terms of energy production, but also in terms to resolve other problems such as noise or integration in our buildings. Instead, the last paper, I think that as I remember that technology is not only the application of sophisticated technological device, but our scope as an architect, as a designer in general, is to enhance the environmental quality of our life, our environmental, and improve the quality of our life. So if there is no question, I thank you for attending this conference. I invite all of you to follow the following section. And I don't know if Dr. Sala wants to add something.
Thank you very much, Doctor, to have you with us. If anyone from the audience have any questions, I have one question for Fatma. Is she with us still, Fatma?
Yes,
about the solar control?
I hear you.
Yes, I want to ask something. You have very good presentation. I like it, and I want to ask about you deal with the irradiance of the sun, but did you harmonize that with the natural ventilation? Did you do something regarding this issue, or you just focused on the solar radiation in your study? Because as I understood it from you, the percentage of the opening controlling the sun irradiance, while also it is affecting the natural ventilation. Is these buildings are permeable buildings, or it is allowed to be naturally ventilated, or it is not?
Yes, you are right. Thank you for your question. This study scopes limited just solar radiation, solar control, and sun exposure, but it's must had to evaluate the wind speed and natural ventilation, because the direct related for the thermal comfort, but we just calculated the solar radiation and sun exposure view factor and related to solar control, but the next studies can be evaluated the natural ventilation.
Okay, thank you. Thank you, Fatma. And I have another question for Fajr. Is she with us?
Yes, I'm with you.
Yes, you have mentioned, I have one reflection about your work. You have mentioned the working environment, and you focused, I think, on the social issue. Okay, I agree 100% that the scenery, the interaction, it's all helping to reduce the stress and to increase the productivity in the work. But in the same time, as an architect, we have to think about the environmental issue. Especially, you had case studies in Bahrain, which is a hot and humid area. Open space, I think it will give extra burden on the loads in the building. We have to think, okay, as an architect, we have to find solution for both. I mean, environmental issue and social issue. What do you think about that?
Yes, I totally agree with you. The climate is really affecting the architecture, and how could we design a building that respects the architecture, respects the climate, and also respecting the social and the interaction within the building. So I totally agree with your reflection. Thank you so much.
Thank you very much. Professor Maurizio, I don't have anything else. Thank you for your wonderful management.
Thank you, Professor. There are other comments about this section. Other side, we can conclude. Thank you very much. Thank you very much for your time, for your effort, and for your scientific contribution to this conference. I hope that you have enjoyed with this time with us, and have a nice evening, and thank you very much. Bye, everyone.
Thank you, dear Dr.
Thank you very much,
I really
Doctor.
appreciate
We will,
that. And unfortunately, I think we haven't had time at the beginning to introduce our valuable authors. I would like to thank Dr. George Bloomberg, also Dr. Irina Bulak, and Dr. Yenal Akun, which Dr. Yenal Akun has a specific structural suggestion that he proposed. It was very interesting, also in my mind. And I would also like to thank Dr. Fatima and Dr. Nesha for their valuable presentations. Let's continue. And at the end, for Professor Dr. Mauro Sibila for organization of this session, I really appreciate that. We shall give the ground to Dr. Yasser Faragli if he is available. So he may take the session chairship from Mauri Sibila. Thank you, dear Dr. Mauri Sibila.
Thank you to you.
Thank you also, dear Professor Dr. George Bloomberg. If you want to add any specific comment to your study, also extra comments, it would also be great if you would like to add any.
Sure. Well, I think it's a great opportunity and interesting to discuss sort of a range of topics with a group of people. So I guess what makes me interested about the study of blockchains and the use of blockchains is it can resolve some of the bigger issues about data management in renewable energy networks. And this seems to be a sort of a stumbling block, is managing lots of different devices and systems. And the other thing is that it's community driven. In other words, it starts at the community or individual level and works upwards rather than being a top down or centralized system. So this kind of community based data management and reconciliation system is very attractive for governments when it comes time to try to comply with our carbon reduction goals, our carbon reduction targets. So I think that the research is really motivated by the ability or by the opportunity to try and figure out easy ways to manage and reduce carbon using carbon trading techniques. And this way to sort of bit by bit in a small manner improve carbon emissions. So that's sort of the energy, the enthusiasm I have behind this particular research.
Perfect, perfect. Thank you very much. Very nice, professional, abstract and conclusion for your study. I really appreciate that. Dr. Yengal Akun, also, if you have any specific comments, also, it would be perfect to have your opinion about your study or conclusion, or if you think that anything is missing from your project. So if not,
are you asking me? Did you ask me that question?
no, sorry, Dr. Yengal Akun, our third presenter, the review of contemporary adaptive structure and future perspective. I think he left, Dr. Yengal. He was around, but now I can see that he's not in. So we shall, I think, give the floor to Dr. Yasser Farajli to start his own session of architecture and technology by focusing more on environmental studies, with the session co-chairship of Dr. Mariam Iranfar. So if Yasser Farajli is around, if not, or Dr. Mariam, if you have anything to add to start, we shall go directly to the presentations, if you don't mind.
Sure, Doctor. This is the fourth round table in architecture and technology. The first presentation, it will be about the international between restorative environments and visual performance in university campus landscapes. Shall I start with the first presentation to share?
Yes, if you please, let's see whether if you could do it.
The author is here.
Perfect. If you can manage to share the video.
Okay. One minute, I will share it.
So the presentation will be about Dr. Yasser Farajli, Dr. Nermin Alhani, and Dr. Yasmin Mousa, working on the interrelation between restorative environment and visual preferences in university campus landscape. So,
yes. Okay, I will share it. Is it, the sound is okay?
No, I don't think it's working.
okay, I think I should also take the responsibility. If you
I think we have a problem with the connection. It is not very strong enough.
Yes. Please, Dr. Mariam, if you stop your sharing, I will share from here.
Hi, dear conference participants. Welcome to my presentation.
Is it working?
Dr. Mariam, I think you have to stop sharing.
Can you?
Doctor.
Is it working, Salah?
Now I will stop to sharing. My connection is not good.
I have organized the course in the following section: introduction, methodology, design of 2D and the alternatives, environmental noise modeling, evaluation of findings, and discussion and conclusion. The first point concerns the issue of air traffic noise. Although noise and energy in general do not have a direct relationship, the transportation sector is responsible for a major share of energy consumption. Additionally, transportation has many phases related to environmental pollution, such as air and noise.
Something else is being shared. I don't think it's not the same paper.
Of air traffic and energy and noise pollution. Noise barriers can be the best solution when more noise control measures are taken, either.
You mean that it's not sharing? I'm not. It is, I think it's working.
Noise barriers are.
This is not the presentation.
Dr. Huraksh, this is not the presentation.
No.
Second one.
Dr. Huraksh, if you hear me, this
Yes,
is
yes.
not the presentation that we
I got
should,
it. I'm going to share a new design proposal. Am I right? So let me share this one. A new design proposal.
I am a doctorate student at architecture and I am a research assistant at.
No, we have seen this one, my dear.
Dr. Huraksh, should be the interrelationship between restorative environment and visual performance.
I think this one.
Reference.
Yeah, this one.
Yes, this one. Yes, thank you.
Experiencing nature has become difficult multiple disorders such as anxiety, stress, and depression. And statistics also show this, where stress is the main cause of 60% of all in university campuses. And most educational settings require high levels of attention and creativity and productivity. And this attention causes them to suffer such mental disorders. So the question is, how can designers create outdoor restorative environments for such stressful settings? So the first point we'll be discussing is restorative environment. When a person perceives an outdoor setting, usually this perception is through sensory input. Studies show that more than 80% of humans receive input through vision. That's why environments are primarily visually perceived. However, visual perception requires preferences, or is controlled by preferences. And people have specific landscape preferences, and that's why the second point we'll be discussing is visual landscape preferences. Finally, for a person to perceive outdoor campus setting, there are specific requirements for campuses. These considerations will also be studied through the literature. So this is the third point. However, there are no coherent frameworks which correlate with the mentions of restorative environments, visual landscape preferences, and campus design considerations. Therefore, this study focuses on creating a comprehensive assessment tool for understanding the perceptual dimension and the physical dimension of restorative campus environments through a literature review. And finally, the perceptual dimension leads to the creation of a perceptual framework, and the physical dimension will lead to the creation of a physical framework, and finally, a comprehensive assessment tool to understand better how our campus landscapes outdoors restorative environments. First of all, the physical dimension is a perceptual dimension. Restorative environments are designed to create such feelings such as contemplation or healing effects for people. That's why they're important. And there have been two theories on restorative environments, AOT and SRT. The AOT states that restoration takes place when a person focuses when they direct their attention in an involuntary way. And it has 4 stages, and there are specific points or specific qualities that are required for this attention, which are being right, destination, extent, compatibility.
However, the stress reduction theory developed by Roger Ulrich states that it's a rapid response to the total configurational properties of the scene, and they're based on preference judgments. So this takes us to the second point, preferences, visual landscape preferences. So if a person is stressed and they're exposed to a stimulating environment, they're more likely to become healed. There have been also two frameworks. The first is Roger Ulrich's model, and the second is a developed version of it by Tibet. So this is Urbanism. Mainly, many different theories were studied using this framework, and they developed or created 9 visual landscape preference indicators. These indicators are complexity, coherence, disturbance, stewardship, imageability, visual scale, naturalness, and ephemeral. So this is a summary of the 9 visual concepts and their dimensions, definitions, landscape attributes, and potential indicators. Here's an example for stewardship, and here's another example for imageability. So, however, when we're talking about perception, there are specific variables that have to be considered, whether it's cultural, individual differences, or physical landscape. And these variables cannot be ignored as they might alter the response. So mainly most of the variables from the literature were grouped into this table, and they were accordingly classified into 4 different categories, with 4 different types: safety, activity, familiarity, and data accessibility. Second is the physical dimension. First, we will be discussing the campus physical dimension in general, and then we'll go through the specific facts concerning the meso and the micro level constituents of restorative campus landscapes. The first level is the macro level, where studies have shown that campus morphology has major planning problems such as insufficient square footage, diminished quality of buildings, facilities, spacelessness, and so on. So really, campuses do need development. Meso level, there are different configurations, spatial configurations from meso levels and university campuses, such as the home base, front porch, front yard, backyard, and turf. And finally, the different types of landscape elements, which include soft landscape, hard landscape, water bodies, materials, and modern elements. So according to these classifications, we moved on to the restorative campus physical dimension. First is the meso level. Based on campus outdoor spaces, general design recommendations were added using framework. And according to the micro level constituents, there are different elements that, if are present in outdoor spaces, can enhance the restorative health, as well as water features noted like vegetation, landmarks, balconies, street structures. As you can see here. So this table is hence developed with the 18 landscape constituents, and then the restorative qualities and the design considerations. So, for example, this part, the sensory reading palette helps in lead away with positive distraction, and the design considerations for it that it should have foliage that easily moves to draw visual attention, and inviting tactile qualities. Finally, this is the developed perceptual framework according to the restorative concept, visual preferences, and spatial usage dimensions or variables. And this is the physical framework according to the meso level and macro level constituents of campus landscapes. Finally, these 2 frameworks have been merged into a campus assessment tool, and this tool shows the relationships between. For example, for being away, if there are water features, then it enhances the quality of being away. However, if there are no natural landmarks, identity or place-based relationships will be impacted. So this framework can be used to assess the shortcomings of campuses and understand how resources work in the spaces. The perceptual dimension requires individual opinions, while the physical dimension requires visual survey. So it doesn't need personal, so it only needs professional opinions. And while using these two frameworks, one should consider the variables that can alter perceptions, such as gender, restoration, age, economics, and social experience. Finally, the notions of restorative environments and visual preferences can significantly improve people's lives, specifically in university campuses where people are constantly stressed. This can also be used to provide information on shortcomings of landscape campuses and deliver guidelines on how to create better open spaces. However, further studies are required to implement it and improve its scalability in different landscape settings. And further research is also required to develop a method for statistical analysis using the proposed tool.
Thank you very much. I can see that Dr. Yasser Farakli is here. Welcome here, Dr. Yasser. How are you?
Hello, how are you?
Thank you very much. Sorry
I think this session started a bit earlier than the planned time, right?
Exactly. That's please accept my apologies. And
no.
The platform is yours, and I just finished the first one, and you can have your introduction and share the authors and introduce the authors as you wish. So the platform is yours.
Okay.
Thank you.
Thank you very much to take over, and sorry for the delay, but actually, as you mentioned, we started a bit earlier than the planned time. So shall I proceed for the next paper, or
as you wish? You are the chair. As you wish. Yes, please.
Okay. Okay. Okay, thank you very much. Thank you very much, Professor Yasmin. I really appreciate your effort and your presentation. And now we'll start with the second paper entitled The Influence of Diverse Building Height and Building Coverage Ratio on Outdoor Thermal Performance in Hot Climates. The paper presented by Mariam Ashraf Adli and Omar Galal. So we'll start now with the second paper.
Hi, this is Mariam Ashraf, and today we'll discuss the paper titled by The Influence of Diverse Building Height and Building Coverage Ratio on Outdoor.
Just a moment.
Hi, this is Mariam Ashraf, and today we'll discuss the paper titled by The Influence of Diverse Building Height and Building Coverage Ratio on Outdoor Thermal Performance in Hot Climates, a review. So briefly starting with the introduction, although urban form can significantly affect outdoor climatic conditions, urban planners do not sufficiently consider such impact while designing new urban communities, and this problem highly appeared in Egypt while the government set its ambitious urban strategic plan to relocate its inhabitants from the highly dense populated Nile Valley into the uninhabited areas of the hot deserts, which is 94% of Egypt's lands. Unfortunately, most of these cities are featured by hot arid climate with relatively high temperatures. So in order to be eco-friendly, this urban development needs a special criteria from decision makers and urban planners to design in such climate, a harsh climate, which should passively ensure good ambient conditions. Usually studies that are interested in microclimate and the relation between microclimate and urban form are focused onto three morphological parameters that are aspect ratio, which is simply the relation between the height of the buildings overlooking the street with respect to the street width. Secondly, the sky view factor, which is the proportion of the sky that is exposed to a specific position within the urban environment. Thirdly, the orientation, which is not only the orientation of the streets, but as well as the orientation of the buildings as well. So the problem is that new cities are not compatible to their climate. All social housing in new urban communities such as New Cairo, New Okra, and cities in Upper Egypt suffer from the following. First, by commitment to unify a prototype, which is ground plus 5 floors, for rapid execution and fixed cost without taking in consideration the street width or its orientation, which affects the quality of life for social housing residents. Secondly, high sky view factor values, which results into lower aspect ratios, as a result less shaded areas. Moreover, urban planners preferred curvilinear street network as an aesthetic scene, which no longer set up a leading orientations. Consequently, all of this had great influence on the microclimate and the pedestrian thermal comfort. Reviewing the prior literature, it can be classified into studies that dealt with urban canyon geometrical parameters such as aspect ratio, orientation, sky view factor, and manipulation of building heights, as well as urban form, shape, and size. Moreover, building typologies, whether it is attached or detached. All of these studies were analyzed to find gaps which can lead us to find a new approach. First, discussing the studies which focused on the influence of canyon orientation and aspect ratio on thermal comfort. Rodriguez 2016 in Cuba's Savannah climate used Rayman simulation model to investigate a symmetrical urban street canyon with 9-meter width and 380-meter long in a zigzag urban form, who tested different solar orientations under different aspect ratios from 0.5 to 5. The street canyon was subdivided into 5 equal sections with 1.5 meter apart. The results revealed that the north-south orientation is the best orientation for summer, with aspect ratios ranges between 2 to 5. Also, when point E is the best for north-south orientation. As for the east-west orientation, aspect ratio should be more than 0.5. And in summer, it should reach 1 with the addition of trees. Also, a local study in New Cairo, hot arid climate, which by Shafri 2018 reached to nearly similar results in an aligned urban form, that in summer, the north-south orientation aspect ratio should be 3, not more or less, and with east-west orientations, aspect ratio 1 is the most preferable for the east-west orientation. Moving forward for the studies that focused on the impact of urban geometry, aspect ratio orientation, and sky view factor on the urban microclimate, Borbia in 2010 in Constantine, a semi-arid climate, found that the surface and the air temperature increases when the sky view factor increases and the aspect ratio decreases. Another study focused on the impact of building typology on microclimate and thermal performance as well. Yahya and Johnson in 2013 in Damascus, Syria, modeled using MVMAP 2 residential zone in New Damascus, detached building of 0.31 aspect ratio and 0.83, and compared it to the attached buildings in the Old Damascus of aspect ratio 2.95. The results emphasized that the highest PET values was found in the middle of the street in the New Damascus of 50 degrees Celsius at 2 p.m. in the modern zone, while the lowest was in the Old Damascus buildings with attached buildings. Recently, in 2020, Shrif and Abu Hajla studied the influence of manipulating building heights on outdoor thermal performance. First, he simulated the base case with uniform building height ground plus 5 floors, and the results indicated that the north-south orientation is surely the best, while the worst orientation is the northeast-southwest, with the difference between the previous orientation 1.84 degrees Celsius. Then he compared it to several cases in the whether in the short direction or the long direction. However, the results revealed that the short axis obtained better results due to the effective height variation than the gradual variation in the long direction. A local study focused on the impact of urban form on PET in new urban cities expansions. By Galal 2020, first a quarter in New Aswan city with curvilinear urban form were selected and calibrated via NVMAT after taking measurements from New Aswan University. Next, compared to 4 quarters in Great Cairo regions with different urban forms were either irregular, zigzag, radial, or zigzag anyan, and the results appeared that the highest average PET values and air temperature were in New Aswan and the lowest in the Mohandisin quarter, with difference of 8.14 degrees Celsius. The research also recommended floor area ratio of 7.6 and enclosure factor 90 for hot climates, with aspect ratio approximately 3 and orientation north-south or northeast-south. And this should lead us to a new approach in our research that focuses on urban blocks, standard deviation of building heights under different orientations, and floor area ratios and building coverage ratios as well. Quarter in New October, which is a result of 6 October city expansion, is taken to illustrate the idea more. Here are the suggested scenarios against the base case, which is characterized by ground and 5 floors, building coverage ratio 0.34 and floor area ratio 2.04. In the first scenario, the building heights were raised to ground and 8 floors for all the apartments, while in the second scenario, the front and the back of the urban block is raised in height for ground and 8 floors, while the middle of the urban block stayed the same. In the third scenarios, it is just the opposite of the second scenario. Here we can notice that the floor area ratio increased in these scenarios against the base case. Increase in
Well, thank you very much for your presentation. Well, thank you very much for your presentation. Actually, very interesting topics, including building heights, orientation, aspect ratio, thermal performance, are very important issues, especially with the new extensions witnessed by Egypt right now. So now we'll proceed for our next presentation. Okay, so the next presentation would be the development of aperture at residential buildings of Mediterranean climates for mitigation of carbon emissions. The paper will be presented by Dr. Mariam Iramfar, Dr. Salar Mohieldin. And now we'll start this presentation.
Do you love Gantt charts? Here's how easily you can build one in ClickUp. Let's map out.
Hello, everybody. My name is Mariam Iramfar, PhD in architecture. The title of my article is The Development of Aperture and Residential Building of Mediterranean Climate for Mitigation of Carbon Emission in Kyrenia, Northern Cyprus, as a case study. Global warming, as we know, it is a significant threat for the countries which they are located beside the coastal areas, because each 10 centimeter rise in sea level will increase 10 millimeter square strips of the coastal area around the world. Carbon dioxide emission from the building increased by the using the fossil fuels or indirect using of fossil fuels through the electricity. The building sector consumes more than 40% of global energy and produces 24% of greenhouse gases. The current study tries to reduce the carbon dioxide emission in residential building in Kyrenia, Northern Cyprus, with understanding the effect of the aperture, physical characteristic of the aperture on the energy consumption. Mediterranean region is one of the distinguished climate change hotspot and most responsible region for global warming. Aperture is defined in this case study as a transparent opening, outer glazing area, and they are also important to adding aesthetic value to the building design. Kyrenia in Northern Cyprus has selected as a region for the case study for two reasons, which is unique topographical character, which includes the coastal area, inland area, and mountainous area. The study hypothesizes that understanding the physical characteristic of outer glazing areas with the respect of excellent view, mountain view, and sea view can develop the architectural environmental design criteria in Mediterranean climate. The aim of the study is to develop guidelines for aperture physical characteristic for lower carbon dioxide emission in the buildings, which assist the professional and government to legislate the new building rules. Two questions has been conducted in this research: how much the aperture physical characteristic in the residential building of Mediterranean climates affect building CO2 emission according to the limitation of the current study, and how much is proper to develop a model to calculate CO2 emission through resizing the glazing elements or the window wall ratio to reduce CO2 emission in residential building with excellent view as sea view and mountain view. The methodology case study samples selected in Kyrenia in Northern Cyprus, 30 existing residential buildings with various topologies like detached, houses, semi-detached houses, or apartment blocks in Kyrenia has with different topographic characteristic of Kyrenia, as such as coastal, inland, and mountainous areas has been selected. The height of the selected buildings is limited to 3 floors to neglect the different factors which is happening with the increasing of the height, like wind speed. The study will focus on the buildings with 2 main following orientation: northern orientation, sea view, and southern orientation, mountain view. This is the 30 case studies selected in different districts of Kyrenia, like Lapta, Alsancak, Karagloglu, Karaman, and the observation method. Direct observation method for collecting data is including the classify the types and materials of the aperture, grazing area, and frames for the existing building in coastal area, inland area, and mountainous area of the Kyrenia. Determining window to wall ratio, WWR, in the residential building in Kyrenia. Identification of the building envelope type for the collected samples. Including non-transparent elements like roofs, outer walls, and floor. This is the 5 different frames and glasses in the case study samples. The most common and prevalent was the first one. Design builder simulation software. The model was developed based on existing data collected during the different fieldwork for the selected sample buildings. The first step in the design builder simulation was to create the eventual model regarding the selected sample buildings with floor area 10 by 10, 100 meters square. A single family unit is without basement and like cubic shape. The aim of the modeling is to simulate real condition according to initial indications. The climate condition of the sample building is simulated in the design builder. This is the one sample of eventual model for the study in summertime, in sea view, in morning, noon, and afternoon. This is the different tabs in design builder, software, location tab, which is include the location details, time zone, weather simulation, wind speed, and direction, and site tab, which is belong to latitude, longitude, and height of the above the sea. How the location of the sample is defined by latitude, longitude, and elevation above the sea. And this is, I found it from the topographical map of Kyrenia in Google, which is for the coastal area between 0 to 10, for the innerland 10 to 60, and for the higher, the mountain between 60 and 300. The weather simulation has been applied according to 2 main seasons, summer, July and August, and in the winter, January and February. This is the activity tab, which is explaining the factor. Activity factor for men is 1, for women is 0.85, for children 0.75, and the householding intensity is 20%. This is the sample of roof material and U-value calculation with design builder software. According the construction material were selected based on the direct observation of the selected sample buildings according to 8 of plans and available CAD files. This is the glazing tab, which is identify the glass elements of the building. The focus of the study is with the windows and doors, glass windows and doors. From WWR and the dimension of glazing area on the eventual model, southern and northern ones. There are 3 different WWR applied in this research in order to understand the effects on the glazing size and CO2 emission in Kyrenia according to this climatic condition. This is the percentage in northern direction, southern direction, maximum WWR, average, and standard, and the size of the windows. And type of glazing area on the eventual model. According to the observation for the window types in Kyrenia building, commonly one type of window glass prevailed. like double clear. And three different types have been suggested based on their cost and accessibility to apply in eventual model, to compare them in the simulation result to find the optimum CO2 emission through the windows in both sea view and mountain view. This is double clear, double gray, and triple clear glass. The electricity consumption is considered as the analysis and findings. The electricity consumption is considered as a major factor for estimating CO2 emission in the selected building samples. The majority of the sample buildings uses active heating and cooling system to heat and cool their units. Passive heating and cooling system are used less frequently in sample buildings. This is the annual carbon dioxide emission in coastal area, sea view and mountain views with different WWR and glass material through design with estimation. This is the table with double clear glass, double gray, the triple gray in north and south, and this is the numbers for maximum WR, average WWR, and standard WWR. This is the same, but for the inland region. And both regions, coastal area and inland area, have similar climatic characteristics and same solar radiation. During the simulation in design builder, ventilation and thermal bridge were not taken in consideration. The simulation focuses on the effect of window type, size, and energy consumption and CO2 emission in selected sample buildings in Kyrenia region as a limitation of the study. This is this annual carbon dioxide emission in mountainous regions, sea and mountain view, with different WWR. This is the table for mountainous. And from the tables, this is the result analysis of sea view in coastal area buildings. The production of CO2 emission in summertime is more than wintertime. Maximum WWR leads to consume more energy than standard and average WWR. Cooling system consumes more energy than heating system by 2 times. Triple clear glazing is the more proper than other types, means double gray and double clear. Maximum WWR produce more than standard and average WWR. This is the analysis of mountain view in coastal area buildings. Energy consumption and CO2 emission in summertime is more. Maximum WWR producing more CO2 than standard and average WWR. Cooling system is consuming more energy by 3 times of heating system. Triple clear glazing is the most proper. But double gray only for summertime is proper also in this direction. Cooling load is more than heating load in the comparison of heating and cooling load. Analysis of sea view in mountain area buildings. CO2 emission in summertime is more than winter time. Also, maximum WWR produce more than standard WWR. Cooling system is consuming more energy than heating system by 2 times, and triple clear glazing is more proper than other types. Also, this is analysis of mountain view in mountainous area building. CO2 emission in summertime is more than but lower than other regions. Maximum WWR is producing more than average and standard. Cooling system is consuming more energy than heating system by more than 3 times. Triple clear glazing is the most proper glazing than others. Cooling load in mountain view more than sea view by 14% when WWR is bigger with double clear glazing. A relationship between WWR value and carbon dioxide emission in Kyrenia. A linear regression analysis has applied to determine the relationship between CO2 emission and WWR value in different topographical area in Kyrenia, with consideration 3 different glazing types. The relationship will help to evaluate the CO2 emission per year according to the increase of WWR value and vice versa. The result shows very strong correlation coefficient, which is equal to 1. This is the table that we got it from the linear correlation. Conclusion. Studies show that there is high energy consumption and CO2 emissions to maintain comfort in the residential buildings in Kyrenia. The study suggested different materials to help in the mitigation of CO2 emission according to the building view and the location within the three areas, coastal, inland, and mountainous. The study suggested a mathematical model based on linear regression formulas to help the professional to evaluate CO2 emission through the WWR value in each area with different views. This is also show that linear WWR CO2 emission production in Kyrenia become more. CO2 emission in sea view is more than mountain view, and also CO2 emission in coastal and inland region is more than mountainous region, and sea view building in mountainous region can have bigger WWR by 33% compared to other to achieve the same CO2 emission. This is the references. Thank you.
Well, thank you very much, Dr. Mariam. Actually, you really targeted many of the important topics and very in-depth studies related to building materials, opening ratios,
Good grammar and spelling are important, but if you want
also the glazing size in relation to carbon emissions. So thank you very much for your presentation and study. Now we'll proceed for the final presentation for this part, and we'll start some discussions related to questions and answers. So our last paper in this part will be sustainability in architecture, low-tech or high-tech. The paper will be presented by Dr. Seida Emikci, and I hope that I pronounced the name correctly.
Excuse me, Dr. Yasser, is the author is here?
So, can you hear me?
Professor at Ankara University. As you all know, the concept of sustainability has been becoming more and more important all over the world. It is an urgent need to make all processes sustainable in order to protect environment as well as human life. Many technological innovations are emerging to ensure sustainability. This rapid development, especially in architecture, make it increasingly difficult to distinguish the concept of sustainability and technological innovation from each other. Sustainability has started to take place in our life, a completely technology-oriented concept. This presentation is to seek an answer to the question of whether a concept of sustainability in architecture can be achieved with low technology through this article. This presentation also discusses which approach should adopt to ensure sustainability. Climate change is one of the biggest problems facing the world today. The vast majority of the research on climate shows that human activities can cause rapid change in climate. They cause serious environmental damage. Cities or urbanization are the main contributor to climate change. Although cities cover only 2% of the Earth's surface, they consume approximately 80% of global energy. They are responsible for more than 60% of greenhouse gas emission. If we break down by the sectors, more than a half of the energy consumption by cities comes from buildings. This means making buildings sustainable, one of the most fundamental things that can be done to fight climate change. So, what is sustainability? Sustainability, in its broadest definition, development that meets today's need without compromising the ability of future generations to meet their own needs. According to this definition, we are able to say that sustainability definition centered on humans and the environment. Along with the development of the technology, it started evolving into a concept that centered on technology. Many studies state that sustainability should be taken together with technology. Sustainability in architecture start to be perceived as a technology-oriented concept. The effects of the climate change are increasingly felt. At the same time, it is recorded in technological developments. This triggers the trend towards high-tech solutions to reduce climate change effect. However, before the Industrial Revolution, architecture was vernacular, as local materials were used and built according to local climate conditions. Now this completely changed, but still many architects support architecture should be vernacular. And others argue that it is a good method to equip building with the technology. Vernacular architecture consists of the experience of people living in different climate conditions through trial and error. The vernacular architecture provides us not only saving energy but also living in healthy building. On the other hand, technology makes our life easier and more comfortable. In doing so, it aims to control and optimize resource usage. Technology makes buildings remotely monitored and accessible and controllable, and it can offer sensor and device to meet the needs of their inhabitants. Technology in architecture can take action to ensure energy efficiency and thermal comfort after these measurements. Some studies believe that technology will play an important role to transition to low carbon energy system. In addition to that, technology provides new services such as elderly care, child care, security, assisted living, health monitoring. And now, time to discuss and time to decide which approach is more sustainable. On the one hand, the vernacular architecture approach tends to favor the minimum energy and local material required to construct, repair, and operate a building. On the other hand, high-tech solution aims to improve the quality of life of the inhabitant by offering new services or more efficient control and management of existing surface. Therefore, it is necessary to combine high-tech and low-tech solutions in order to eliminate the disadvantages caused by both approaches to make buildings sustainable. This presentation suggests appropriate technology, which means readoptions of traditional local architecture that really takes local conditions and local needs into account without rejecting that technology has provided undeniable benefits. The concept of appropriate technology in architecture refers to the period from extraction of the building material to the end of the life of the building in new buildings. This process should be handled holistically with the help of both technology and vernacular architecture passed down through generation. Appropriate technology makes buildings not only vernacular, but also the opportunity to be smart. Thank you for listening to me. Thank you for your patience.
Thank you very much, Dr. Saida. To close this. Thank you very much. And now we will start the roundtable for discussion. Actually, we have some more time than the planned because we started this section earlier than the planned time. So we still have more time than the planned for the roundtable discussion and answers. So I would like to welcome any questions for the presenters. If you have any questions or discussions or comments for the presenters, that will be very interesting. So if anyone has any questions, you can raise hand on the participant panel. So we'll organize this discussion. Any questions?
I think Dr. Salar has a question.
Thank you. I couldn't catch up with all the presentations because I have problem with my internet, unfortunately, but I could see the presentation.
I can't hear you.
Do you hear me now? Hello?
Yes, I can hear you.
Oh, okay, okay. Yes, please.
Yes, I have a question regarding the first or the second presentation, the influence of diverse building height. I saw that the authors, the researchers had some dealing with the orientation of the streets and how much it will affect the thermal performance and such things. I want to ask, does the traffic movement of or the traffic density should be involved in this process, or it is neglected? Because as we know, the traffic has a big role in as a heat source and the pollution source. Just I had this question, if you answer me.
Yes, thanks, Dr. Seller, for your inquiry. While this research focused on not only the orientation, but the rural and the heights and the floor area ratio and the building coverage ratio as well. Whether actually it was focused on social housing, and the anthropogenic heat from the traffic is not that much, so actually it wasn't the dominant factor in this research.
Okay, so was that clear, Dr. Salar?
I didn't hear the answer. I will prefer to write it to me if it is possible, because I am not hearing very well. Sorry, it is my problem, not the problem of.
Yes, she mentioned
is not
that,
yours.
Yes,
Just
could you hear me? Would you like her to repeat what she said again, if you now hear, if you hear well now?
If it is possible, because I'm hearing now well, if it is possible.
Yes, sure.
So, Dr. Mariam, would you kindly
Yes,
repeat
sure.
what? Yeah.
Okay.
Sorry for disturbance.
No problem. So I was saying that this research mainly focused on not only the building orientation, but the building footprints and the manipulation in building heights and floor area ratio. So as this was the gap in the previous research, so it was focused on social housing buildings where there isn't so much traffic there. So the effect of the anthropogenic heats is not that much, so it was neglected.
Thank you. Thank you very much.
I think this opened the opportunity for further research and future research that can study specifically your point in a specific paper. So
Yes.
this could be an extension.
Exactly, this is correct.
Sure.
Yeah. So maybe.
Thank you.
Okay, thank you very much.
Thank you very much.
Thank you. So also there was a question. Yes, Dr. Zainab Medjeldi is having a question to Dr. Saida. So Dr. Zainab? Dr. Zainab, are you available now? Okay, so until Dr. Zainab rejoin again. So she wrote this question for me. I can read her question to Dr. Saida. She is asking, please, which kind of technology can really help building to be smart? Give us some examples, please, and thank you. So Dr. Saida? So can you hear me? Anyone can hear me right now?
Dr. Saida is muted.
Dr. Saida is not available now?
She is muted. She is muted. Please unmute Dr. Saida.
Okay. 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 So.
Okay. So now it's okay.
Yes, Dr. Saida. Now you can. Dr. Saida? Hello, Dr. Saida? Okay. So she has connection.
Maybe her connection is very low.
Yes, yes. So if you can write your answer to Dr. Zainab Medjeldi, that would be thankful. She was asking about, she would like you to give her some examples of the smart technologies used in buildings. So she was asking exactly what kind of technology can really help building to be smart. Would you kindly send her some example for this, for your idea in this paper? So any other questions, please? Any other questions? Okay, so actually this session or this first half of the session was very rich in many topics, including building heights, orientation, aspect ratio, thermal performance, Mediterranean climate, also some issues related to landscape at the very beginning. And actually some of them followed the traditional approach, and some others followed building simulation using computer tools in order to have some weather and temperature data. So that was very helpful and very interesting field. So now we still have time for the beginning of the second half of this session. The second half of this session should start at 15:05. So would you like to proceed with the next papers, or?
Yes, sir. Sorry for intervention. If you are sure that the authors are available, so we can continue.
Okay.
What do you think?
Yes, we can continue definitely for the second half. I'm just wondering if any other would like to join at the scheduled time, so we'll let him join in the correct timing. But I have no problem. If you would like to proceed, that will be fine.
I think we can proceed if the authors are available.
So,
in order to present with their attendance, I mean.
Actually, we are the next one in the presentation. We are here with my co-author. We can continue if you.
Okay, so okay. So let's start with the second half of this session. The first paper on this second half will be Climate, Site, and Light, Revisiting Critical Regionalism through the Works of Architects. This paper will be presented by PhD candidate Onku Azalp. I hope I pronounced the name correctly, and Dr. Saliha Aslan.
Thank you for your introduction.
Thank you very much.
For the presentation. Welcome everyone. Before the presentation, I, Öncü Özalp, and my co-author Saliha Aslan would like to thank the organization and scientific committee of the symposium, as well as the listeners for their contribution. Today we will talk about Climate, Site and Light, Revisiting Critical Regionalism through the Works of Architects. The emphasis on environmental aspects such as topography, climate and light were brought into consideration as critical responses to the placeless and universalist aesthetic of modernist designs through Kenneth Frampton's theoretical concept entitled Critical Regionalism. It not only emphasized the relevance of climate, topography, light, and site, but also provided a high sensitivity and thought-provoking discussions in approaching those concepts. In this presentation, we will revisit Frampton's concept of critical regionalism, elaborate the examples which were given by him, and shortly provide counter-arguments related to this concept. In this regard, we are also inspired from the article entitled Critical Regionalism by Tom Overmaid, Veronique Patiou, Lee Katerina Shitka, and Hans Tiders, which will be highlighted in the final section of this presentation.
Before elaborating his conceptualization of critical regionalism, Frampton notes his critical stance on modernism's universal validity and his position regarding populism or sentimental regionalism as, quote, a critical regard has to remove itself from both the optimization of advanced technology and ever-present tendency to regress into nostalgic historicism or the glibly decorative. It's my contention that only an regard has the capacity to cultivate a resistant, identity-giving culture, while at the same time having discrete recourse to universal technique, unquote.
On the articulation of the concept critical regionalism, he notes, quote, the fundamental strategy of critical regionalism is to mediate the impact of universal civilization with elements derived directly from the peculiarities of a particular place. It's clear from the above that critical regionalism depends upon maintaining a high level of critical self-consciousness. It may find its governing inspiration in such things as range and quality of the local light, or in a tectonic derived from a peculiar structural mode, or in the topography of a given site. In elaborating Aalto's Saynatsalo town hall, Frampton gives particular emphasis to the sensory experience of the building. For instance, the stairs of the public circulation in the building and its finishing material suggest a friction which reflects on the visitors as a distinctive kinesthetic experience. For Frampton, the significance of tactile is highly related with the notion of physical experience, and the tactile qualities arouse a poetic consciousness for the architects which is related with forming place form. As he puts, quote, "The tactile and the tectonic jointly have the capacity to transcend the mere appearance of the technical in much the same way as the place form has the potential to withstand the relentless onslaught of global modernization." Unquote.
Also, how to approach a site becomes very important in the articulations of Frampton with respect to the distinctive qualities of place form. In his own words, bulldozing of an irregular topography into a flat site suggests placelessness. However, thinking about the idea of terracing site into a stepped form recalls cultivating the site. The second way of thinking can generally be critical regionalist. In Frampton, a hypersensitivity is displayed in Caesar's architectural approach, which encourages the configuration of topography with respect to the specificities of both site and locality. With a high consideration of local material, craftwork, and light, the architect transcends rational form and modern technique. Embedding the buildings into topography and increasing tectonic values in architecture can be observed in the works of Caesar, which were topographically structured buildings instead of visually and graphically designed buildings.
For Frampton, the particular emphasis on design reveals the existence of site in Raymond Abraham's project. This imaginary project demonstrates the material existence of architecture as observed through its tectonic form. It transforms the Earth's surface while proposing an interrelated tectonic form with the ground. Following Frampton, Bottas houses display a relationship between buildings and topography as well as insight into landscape. Inspiring from traditional agricultural barn-like structures, Bottas houses can easily be recognized in the landscape, and their configuration relates to the topography with respect to the idea of building the site or cultivating the site instead of aligning with the existing contours of the site.
So far, we have observed Frampton's notes on the architectural examples and how he frames architects as critical regionalists via their approaches and internalization of topography, climate, and site. Although those examples are influential in observing architects from the critical standpoint of an architecture critic, we need to elaborate criticism toward the term for a broader understanding of it. In Keith Eganer's inspiring article, Placing Resistance, a critic of critical regionalism, we observe the writer's critical stance on the term and how the concept becomes insufficient in explaining complex, intricate, and interrelatedness of inherent discourses which emerged in different cultures. For Eganer, similar to the postcolonialist discourses, critical regionalism tends to develop its arguments upon twofold oppositions, such as East-West, modern traditional, and natural cultural. A similarity can be drawn from the notes of Ignacio de Solamorale, which emphasizes his theoretical thinking as a dialectical and thus less monist, less self-enclosed approach, and as a proposal for looking at current architectural scene from a rather dualist version.
The OASI Journal 103 focuses particularly on the concept of critical regionalism. The editors of the journal, Tom Overmaid, Veronique Patiou, Lee Catherine Chatska, and Hans TEDers provide a comprehensive study on Frampton, which is entitled Revisiting Critical Regionalism. For the writers, critical regionalism enlarged Western European and North American architectural history to a certain extent by introducing the works of architects from Latin America, Portugal, Finland, and Spain. Also, with its critical positions towards universality and universalization, critical regionalism contributed to the existing paradigms in the practice of design. For the writers, the specific importance of critical regionalism stems from its relevancy in both design practice and architecture theory. Besides, thanks to critical regionalism, architects in different geographies could have a reference point to comprehend the practice from a larger perspective.
In addition to those arguments for a closer perspective towards the conceptualization of Frampton on the notion of place and space, we can also refer to Charles Holland's article, Building Writing History. As the writer notes, quote, using Heidegger's metaphysics as a source, Frampton distinguishes between the supposed authentic properties of place and the abstractions of architectural and universal space. While place can be experienced physically via physical, haptic, and tactile qualities, space is part of capitalism's abstract systems of value. The cultivation of the physical properties of the site is then, for Frampton, a meaningful way to resist the forces of globalized capitalism. Unquote.
As a concluding remark, we can elaborate that although Frampton's theoretical framework develops upon restricted bipolarities, it pointed out important dimensions of architecture making in evaluating and bringing forward the tactile, phenomenological dimensions, and provided thought-provoking discussions in articulating architects' work in relation to site, light, and climate. We believe the relevancy of those strains related to sensory experience become increasingly important in critical thinking of the destructive impact of capitalism and its infiltration into architectural thinking. Thank you for your concern.
Thank you.
Well, thank you very much. Thank you very much, Dr. Unku Uzalp and Dr. Aslan for the nice presentation. Actually, presentation for studying the correlation between the architect's work and climate, sites, and light. So now, thank you very much.
Thank you.
So now we'll proceed to our next paper. We are lucky to have Dr. Miriam Iramfar for the second time in this session with another paper. So we'll start the second paper entitled The Synthesis of Ethics and Aesthetics in Modern Movement of Architecture. The paper will be presented by Dr. Miriam Iramfar and Dr. Huraksh Ahmadinia.
Dr. Yasser, Dr. Huraksh,
the names.
sorry, Dr. Huraksh Ahmadinia.
We'll start the second presentation.
Hello, everybody. My name is Mariam Iramfar. My paper title is The Synthesis of Ethics and Aesthetic in. Hello, everybody. My name is Mariam Iramfar. My paper title is The Synthesis of Ethics and Aesthetic in Modern Movement of Architecture Through Theory as an Assessment Tool. Significance of the study. The modern movement of architecture represents a dramatic movement in the building design to create a different functional and new architecture. There are debates about the beauty, aesthetic, and functionality ethics in the architecture of early modern movement, which is the concept of this paper. Problems of the study. Architecture has entered the 20th century with an inner conflict between its aesthetic, which claims full independence, and amoral, involved in a social purpose. There is a debate about the priority of beauty, like aesthetic and functionality ethics in this architectural style, and leads to ambiguity in evaluating ethics and aesthetic. This study hypothesizes that there is a significant relationship between ethical and aesthetical values through the functionality of modern architecture. There is two questions. Is there any credible tool to assess both ethics and aesthetic in architecture? And to what extent ethics and aesthetics have presented in modern architecture? The aim of this paper is to reach an understanding of the relationship between ethics and aesthetic in modern architecture. The three main objectives is to understanding the main characteristic of modern architecture is an important issue. Having a critical understanding and identification of the two main concepts, ethics and aesthetic, and how could they interact with each other is an important issue too. The theory of truth has been investigated to be applied as a tool to evaluate the two main concepts of ethic and aesthetic in architecture. This is the figure that shows the interaction between these three objectives. The scope of the study tries to propose a conceptual model to be applied in future studies on different case studies. This is through assessment tools to evaluate the presence of ethics and aesthetic in modern architectural style. Review of the literature. The first one is ethics. What means ethics? The term moral or ethics refers to the ensemble of the rules governing human actions and values and which function as the norm is in society. Ethics as a branch of philosophy has been firmly ensured since Aristotle. The main goal of ethics is to put the human at the priority of care and seek his greatest good. What means aesthetic? The term aesthetic is a Greek word. Means the things perceptible to the sense, or anything could have an aesthetic effect simply when being sensed or perceived. It can be defined as the study of beauty and taste. To understand aesthetic, it is necessary to define the concept of beauty. The word beauty means the things that are giving pleasure to the sense, to the imagination, or to the understanding. Plato said that the beauty incorporates proportion, harmony, and unity among their parts. Also said beauty is the eye of the beholder. Socrates clarified that the aesthetic attitude was a derivative of the practical, useful value of an object. Aesthetic values related to human perceptions and experience and environmental surrounding them. Theory of truth. Truth is characteristic of being in accordance with reality or fact. There is 4 factors for the truth: congruence, consistency, coherence, usefulness. The 4 factors can be guidelines, indicator to evaluate the presence of truth in any issue. Theory of truth has 4 factors. Now we can understand what means the meaning of each one. A true theory is congruent with the observation which is reflecting reality. About the congruence. Consistency characterizes a true theory it contains no contradictions and fits together elegantly. Coherence. A true theory is coherent with other things else believed to be true. Usefulness. A true theory is functional and useful, and the actions are successful when it is acting on the basis of a true theory or explanation. The relation between ethics and aesthetic in architecture. John Ruskin has a crucial step in coalition of ethics and aesthetics. The quasi-identity of these two essential values to a third, which is truth, according to medieval thinkers, constitutes the third member in a set of three transcendental concepts reinforced the link between what is beautiful and what is good. The characteristic of any modern architecture. There is 5 points that characterize the modern architecture according to Mongatta. The supports, pillars, the free facade because of the structural support pillars, rectangular and ribbon opening in the facade, the ability to freely design for the walls, the roof garden. Methodology. The study tries to assess both ethics and aesthetic in modern architecture through the validity of truth factors. As we see, aesthetic, ethic, truth, there is 4 factors for the truth and how they are interacting together to have modern architecture characteristics. Therefore, the descriptive analytical methodology has been approached in this study through reviewing the knowledge. The correlation between truth theory and early modern architecture. The figure shows the type of connection among the factors of truth and the features of modern architecture style. According to the analysis of the relation among the elements of modern architecture and truth factors. This is the truth factors, and this is the modern architectural characteristics, horizontal windows, the supports, the roof gardens, and the free wall designs, how they are interacting together with each factor of the truth. Empirical method to apply to the model. The main aim of the proposed model is to evaluate ethics and aesthetic in modern architecture depend on truth as a tool. There is 3 factors: input, analytical, and result. Here in this figure, we see the first stage, input, the characteristic of the modernist architecture in the selected case study. The second stage, analytical, the correlations of the previous stage with the 4 factors of truth based on the statistical approaches. The third stage, output, the weight of each factor of the truth and collect the outcome to be evaluated by percentage, which considers the presence of ethics and aesthetic in the selected case study. Conclusion. The tool of assessment for ethics and aesthetic in the modern movement of architecture that was used in this paper, according to the knowledge review, was the theory of truth. Strong relations among the factors of truth and features of modern architecture have been found. The study has revealed that there is a multi-level of relations among the factors of truth as a tool for the ethic and aesthetic and modern architecture characteristics. The most correlated factor of truth was usefulness, which demonstrates the interaction with all the features of the modern movement of architecture. This is because of the core philosophical characteristic of functionality in the modern architectural movement. Congruence as the second intercorrelated factor of the theory of truth has shown a very good correlation with the features of modern architecture. The reason goes back to the international and standard character of the modern movement in architecture, which demonstrates similarity in the principles of the design, regardless of the location, climate, culture, and etc. In the same context, the consistency and coherence also have demonstrated good correlation. The model also provides useful insight for a comprehensive understanding of the aesthetic and ethical assessment in modern architecture and helps reduce the rigid controversy in this area. This is the complete evaluation model of ethics and aesthetic in the modern movement of architecture through the truth tool, including all the assessment factors and features. The aesthetic ethics theory of truth with the 4 factors of truth, how they are interacting with the modern architecture characteristic, and finally modern movement architecture final evaluation. Thank you.
Thank you very much, Dr. Miriam. Actually, a very nice presentation. Actually, a very nice presentation studying a review for ethics and aesthetics in modern architecture, studying the role of truth and its factors between ethics and aesthetics in modern architecture. So, thank you very much, Dr. Miriam. And now we proceed for the last presentation in this session. The last presentation will be, yes. So the last presentation is mobility practice. What solutions to ensure the safety of the surroundings of schools? A case study in Tariq Ibn Ziyad School, Guelma. The paper will be presented by PhD candidate Miriam Lamari and Dr. Yusuf Lazri. So we'll start now with the final presentation in this session, and we'll have quite enough time for discussions and questions and answers after this session immediately.
Hello, I hope everyone is doing well. So let me introduce myself. I am Lamari Mariam, doctoral student in sustainable architecture. Hello, I hope everyone is doing well. So let me introduce myself. I am Lamari Mariam, doctoral student in sustainable architecture and urban project at the University of Guelma in Algeria, affiliated to the Laboratory of Civil and Hydraulic Engineering and supervised by Dr. Lazri Yusuf. Today, I am going to talk to you about a very important subject that affects school population, which is the core of society. The subject is mobility practice. What solution to ensure safety of the surrounding of schools? Case study, Tariq Ibn Ziyad School in Guelma City. This work is organized according to IMRAD model, which includes 3 sections: introduction and problematic, scientific methodology, results, and discussion. What to say at first? There are strong expectations that road safety should be taken into account around schools and on the home school journey. In Algeria, many schools have road access and bring together various road users, pedestrians, cyclists, public transport, and motorists. In the current context, motorized traffic continues to increase. As a result, the urban environment has become a source of insecurity for students and parents. This tendency leads us into a vicious circle from which it becomes more and more difficult to escape. We can consider the home school journey of primary school pupils as a special experience, as a specific space-time that engages individuals in a special